21 game. Alice plays the following game loosely based on the game card game 21. Alice starts with 0 points and draws numbers while she has less than K points. During each draw, she gains an integer number of points randomly in the range of 1 to max points, where max points is an integer. Each draw is independent and outcomes of each have probabilities. Alice stops drawing numbers when she gets K or more points. Return the probability that Alice has N or fewer points. Answers within 10 to -5 of the actual answers are considered accepted. Is this a simulation? Are they asking you to do a simulation? Starts with 0, draws points while she has less than K points. Each draw outcomes of independent probabilities. Interesting. Turn the probability has N or fewer points. Integer randomly in the interval. Wonder if there's a formula that you'd want to use here. Let's see. So K is 1, means that she draws 1. N is max points is 10. So she's drawing something between 1 and 10. And stops drawing numbers when she gets K or more points. Turn the probability that she has N or fewer points. So she stops drawing when she has 1 or more points. And she'll definitely have less than 10 at that point. So as she has 1 or more points, probability that she has 6 or less is going to be 6% of the time. 17 or more points, 21 or less. Or probability she has 21 or less, yeah. I wonder if there's a mathematical formula that you'd use here. So so it's even distribution. You can simulate it. I wonder if that's what they want you to do. It has to be K or more. So it's like she rolls 1 through max points each time. And the question is, if she gets more than K, what's the probability that she is still less than N? Alright. Guess I'll start with the simulation method. Like Monte Carlo kind of deal. So I'll do, let's say, trials in the range of, let's say, 10,000. Yes. Success is going to be equal to, there's going to be a counter. And then let's say there's a current total. It starts with 0. And then while total is less than the minimum, which is K, total plus equals a random number from 1 to max points. What is random Python? Random number 1 to n. Math random.randint a comma b 1 to n inclusive random.randint, just randint probably, because it's probably already imported. Is it? 1, 2 max points. And then if at that point total is still less than or equal to the n value, success increments. Return success out of 10,000. Hopefully that's enough precision. And oh, whoops. Not close enough right there. Okay. Guess maybe 100,000. Yeah, this is definitely not optimal. It's gonna be all right. 1,000,000. Fine. So trials is just not gonna get there. 1,000,000 trials is a lot of trials. So how would I think about doing this mathematically, I guess? So with something like binomial distribution, if you have a die, a 6-sided die, and you try to find the probability that you rolled it, and let's say you get more than 20 but less than 24, more than 20, less than 24. Each draws independent outcomes. Seems more like a probability question than a computer science question. Guess what you could do rather than simulate it is you could do a hard count. So instead of saying that there's 10 outcomes, 1 through 10, that have equally likely probabilities, instead of dealing with fractions and percentages, you can say, well, given that each outcome should be equally likely, we can just have a perfect kind of distribution of outcomes and say that if there's like slots 1 through 10, each of those slots can be counted once. And then at that point, the slot at 1 would distribute to the slots that are 1 through 10 bigger than it. The slots up. So because then you can roll random 1 through 10 and add that to the 1, so it'd be like that 1 splits up into 2 to 11. And maybe you make that a count of 1 each there. the number's going to get really big. Or we can make it a decimal, but then the decimal can get really small. How would you keep on iterating that? So if you start with 0, then you get something like 1 through 10 with like a 1 count. And then there's a 1 in the 1. So you get 2 through like 11 at that point. What would you say is in 2? It'd be like 1 plus another 0.1. Or you can do what could you do? Would you have to actually iterate through this the whole time? That would be really slow as well. Pretty darn slow. I wonder if I can solve this probabilistically. I wonder if I can solve this probabilistically. So trace backwards. So say in this example, max points is going to be 6, like a 6-sided die. K is 20, N is 24. So basically roll 6-sided die until sum is at least 20. What's the probability that that sum is less than or is at most 24? How would I answer that without doing an actual million simulations? So if it's 25 or 26, so if it's more than 20, so it's 19. 19 gets to 25 if you roll 6. And 18 can't actually get to 25 at all, so it would be the probability that you get to 19 and then roll to 6 from there. So this probability that you this probability that you end up with 19 on a bunch of rolls. This is kind of a disgusting problem. But it is interesting. It's definitely not something I've really encountered. What would I do? So if I did the 0 becomes the 1. 0 becomes a 1 in the spots from 1 to 6. And that 1 becomes subdivided can I do it without subdivision? So that 1 becomes kind of a second layer 1. And the spots from 2 to 7. And the 1 and the 2 becomes a second version 1 in the spots from 3 to 8. That's just going to be a bunch of for loops though. Seems like it'd take forever. So 0 becomes like a 0, 1, 1, 1, 1, 1, 1. So that's 6 ones, and then that becomes a 1, 1, 1, 1, 1, 1 here. And then this one becomes additional ones here, so it becomes like 2, 2, 2, 2, 1. No, 2, 2, 2, 2, 2, 1. And this one makes this into 3. So it'd be 3, 3, 3, 2, 1. And that's not enough. So what am I doing? I'm miscounting here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. Alright, the one in the 1 spot becomes that. 6 ones, 2 through 7. Then this one becomes ones in these spots. That'd be 2, 2, 2, 2, 2, and then 1. And then the one in this spot becomes ones in these spots. So it becomes 3, 4 threes, a 2 and a 1. 3, 3, 3, 2, 1. And then this one becomes 4s, so 3 4s. 4, 4, 4, 3, 2, 1. This one becomes ones in these spots, so it'll be 5, 5, 4, 3, 2, 1. And then lastly, this one becomes one of these spots, will be 6, 5. Okay, so that's the second iteration of the distribution after 2 rolls, basically, which is, 1, 1, 2, 1, 12, 2 3s, 3 4s, 4 5s, 5 6s, 6 7s. Okay. Then I would have to actually do that every single roll. That seems kind of ridiculous. I did that every roll. It would be precise. But the number of rolls here could be very large. Can't do a simulation. Can I do some sort of simplification? Probably that you get to certain values. Is the probability that you get to certain values. probability to get a certain value. Expected value. I wonder if you could do expected value calculation here. Value. Wonder. Let's try a simple version of expected value calculation here. So we have a single roll. So for example, 2. You have a single roll, 1 through 10. Your expected value of your answer after the roll would be expected value would be equal to 1 plus 10 divided by 2, which is 5.5. And your question is, what's the chance that's less than 6? Can you somehow incorporate that? Probably that's above. Probably that's less than 6. Probably that's more than 6. Probably that's less than 6. Less than 6. Probably that's between 6, 1 through 6 versus 7 or more. So 1 through 6. Yeah, I guess I don't know that probability. I guess it's 60%, but 60%. Do 1 through 6, 60%. Don't think I know how to use expected value for this. Probably that it falls in a certain range. Probability that falls in a certain range. So, I mean, it's the probability that it goes outside of that range. So the probability that it goes bigger than n. Probability that goes bigger than n. So feel like it almost might be dynamic programming. Wonder. Modify 1 through 6. Even distribution. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. Alright, let's do one more layer here. I don't actually fully recall what this would end up being. So the 1 here, I break that into 1s in the next layer. So it'd be 6 1s here. 1, 2, 3, 4, 5, 6. And then the 2s here would actually make these into 2s. And then another 2 here. So this all becomes 3s. And then this 3 here makes these into 3s with an additional 3 here. So this would be 5, 6, 6, 6, 5. Yeah, 6 numbers, right? Yeah. And then the 4 here would break up into 4s here. So it'd be 3 10s, 3 10s, 9, and a 7. Okay. And then this 5 would break up into 5s here. And then 2 5s afterwards. It'd be 15, 15, 15, 14, 12. 15, 15, 15, 14, 12, 5. Is that all I said? Spacing here is, oh my god, spacing here just ruined it. Okay. This thing ends up being 1, 3, 6, 10. Those are triangle numbers, like combinations. Those are combinations. Like 1, 4, choose 2. Pascal's triangle numbers. 1, 3, 6, 10. That's something choose 2. I guess Pascal's triangle and combinations are similar. 1, yeah, 1, 3, 6, 10. Yeah. I guess you'd always end up with Pascal's triangle numbers. Well, Pascal's triangle doesn't really have. It starts with exactly 1, 1, and then it goes 1, 2, 1. But if the Pascal's triangle is more like a Pascal's trapezoid, where the first layer is 1s instead of a single 1, I guess is what we end up with. Very interesting. I think this is what you end up with. Could you formulate an answer based on that? God. Okay. number of combinations to get to a certain number. 1 goes to 0 goes to 1 through max points. Then each of those answers with an actual answer. So from a single distribution, can you get the next distribution? Or from a static value, can you get the distribution later on for everything? Expected value. So after each roll, value-wise, what is the expected value calculation here? Each roll you get max points plus 1 divided by 2 as the expected value of all your distribution after that roll. And then what? And then it gets closer towards smooth curve the more you roll. I guess the more you roll and average it out, maybe. 17, more than 17, less than or equal to 21. So it could be 16 going to 22 or 16 going to 23. What's the probability that you get to 17? The game ends when you're between 17 and 21. Game ends. Can you reset your expected value to the expected value wise it's 0? Expected value wise it's 0. So what if you rolled instead of 1 through 10, you rolled like -5, -5 to 5? So 1 to 10. Say I translate that to -5 to 5. So rolling a, is there a middle number there? That's maybe 11 numbers actually. -5 plus 10 is 5, but then 1 plus 10 is 11. So maybe -4.4 to 4.5, or -4.5 to 5.5. So if you rolled a random number, negative 4.5, negative 3.5, negative 2.5, dot 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 to 4.5. It's kind of equivalent to rolling 1 through 10. So I'm translating. Can I translate like that? So that means at any given time, my expected value of my rolls, the sum of it would be 0. So I'm not changing this thing at all. Expected value of sum is 0. Then if I translate it, then each roll, the expected value is 5.5 less than the other version of the game where I roll 1 through 10. 5.5 expected value less than 1 through 10. So it's like a negative 5.5. Game ends when it's 17 or more. Can I say how many rolls it would take? Hmm. 17 or more. When the game ends, say P is the probability that it's 17 to sum is 17 to 21 inclusive. 1 minus P equals the sum is 22 or more. So close, actually. Or feel like I've seen this. Probability that the sum is 17 to 21 is P. One minus that probability is the sum is 17 or 21 and 20 more than 21, 22 or more. If I could somehow do some sort of expected value calculation here. Know that the roll at any given do a translation, then my EV becomes 0. Expected value 0 after any number of rolls. So if I roll negative 4.5 to 4.5 any number of times, the expected value is always going to be 0. Expected value always be 0. Then I need to somehow map it to 17 through 21. Hmm. 17 through 21. Game ends. So the game could end on a 17 18, 19, 20, 21, 22. Guess it could be 16 is the low before, or is the high before it ends. Then you roll 10, so it could be 17 through 26 maybe. 17 through 26. Hmm. So if I had hmm, moi, random moi, negative 4.5, negative 3.5 to 4.5, randomly, 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 randomly. Each time I'm going up 5.5. So if I would take expected value wise, how many rolls? Like 17 divided by 5.5? 3 rolls? Expected value wise? Hmm. Even if I did 100 rolls, expected value of negative 4.5 to 5.5 would still be 0. So anyway, I'll just add here, this reminds me, there was like a puzzle, reminds, and I'm not sure if this can actually be applied here, but it's kind of a math puzzle where if two players play, let's say, ping pong, where player A needs 7 points to win and player B needs, let's say, 5 points to win. And okay, let's say, I'm not actually saying this correctly, I don't think. Player A needs, okay, so where scoring is positive if player A wins a point, and negative if B wins a point. Player A needs +7 and player B needs -5 to win. What's the chance? And assuming equally likely chance, either player wins a point. what's probability that player A eventually wins? And the answer to this one, or one of the ways to approach this, was like, you think of it as a random walk of a coin going up if it's heads and down if it's tails. And what's the probability that the random walk eventually, hits 7 or -5? And like, what ends up, one way to do it is like, you think that your EV, your kind of expected value of your position of the random walk, is always going to be 0 at any given, or after any number of points. Like if you play 1,000 points or 1,000,000 points, given that A and B are equally likely to win the point, your expected value should still be 0. Like you still expect A to have won the same amount of points as B after that number of, or within that number of points played. So kind of on average, it should be EV 0. So anyways, it should be, given that, that should mean that the probability that it is at 7, or the weighted average should be 0. So which means weighted average of outcomes should be 0, which means that you should have 7 times p plus -5 times 1 minus p equals 0, where p is probability that A wins. So therefore this should be 7p plus 5p minus 5 equals 0 if you distribute the -5, and then 12p equals 5, and then 5/12. Did I do this math right? 2 plus 5. I think this should have been 5/12 seems a little low. Actually, yeah, that's right. Yeah, 5/12. Because A had a higher number of points that they need to get to in order to win. So anyways, it's kind of reminding me of this. If I can somehow do some sort of expected value calculation after a certain number of rolls, 1 through max points, I can somehow translate it. So 1 through expected value could always be 0. Another way of maybe phrasing something equivalent is like A needs to be 7 points above. A needs to win 7 more games than B, and B needs to win 5 more games than A in order for the match to win. match the end. Any case. In order for the match to end, it needs to be at least max, at least k. How do you know how many rolls at least k is going to be? So 17 and 21. So in order for it to be 17 through, you need to expect a certain number of rolls in order for it to be 17. So given that same number of rolls, it could end up earlier than that. Like it could end up in 2 rolls. So 10 and a 7 would end up being 17. But you'd use the expected value, expected number of rolls to end the game. Expected number of rolls to end the game. And then at that number of rolls, if you're rolling negative 4.5 to 4.5, your expected value of the rolls is 0. Probably that you're 17 through 21 versus more than 21. So if you roll 1 time, expected value would be 0. Value would be 0, or you can think of your expected value being 5.5. You roll 1 time, your expected value is 5.5. You roll 3 times, your expected value is 16.5. Expected value 16.5. And probability that it's 17 to 21 times the probability that it is not 17 to 21 has to be average out to be 16.5 after 3 rolls. Interesting. Is that right? Probably that it's less than that. Within that range after two rolls, and outside of that range after 2 rolls has to be equal to EV. That might be right. Can I choose an arbitrary number of rolls? So 17 through 21. The expected value, 17 through 21. Can I use that as a single average? So for each outcome, or the group of outcomes of 17 to 21, can't just take the average of 17 and 21 to use as the singular thing for that group. So I have to do individual, and there's for the group of stuff that is 17 through 21. Group of stuff there multiplied by their probability plus group of stuff that's not there multiplied by their probability. Somehow the EV calculation is going to be equal to 5.5 times the number of rolls. 5.5 times the number of rolls. So how did this thing work out? So that I guess I knew exactly the spot where the ends are. So I knew what the weight to apply to the probability was. But here it's not a single number, it's a range. So I don't know what the weight to apply to it is. 17 to 21. Because after 2 rolls it could end up in 17, 18, 19, or 20. Each of them has a different probability to apply to their weight to each outcome. 17 times the probability that ends up being 17 plus 18 times the probability that ends up being 18 plus 19 times the probability that ends up being 19. All these weight averages should be equal to the average to 5.5 times the number of rolls. Maybe. One through 6, average there is 3.5. And then 2 to 12, the average there is 7. 7. Average is like 7. If I said, most probably ends up being like 8 or 10. 8 to 10. It's like 10 times 5, 36. Plus 4 times all those weights.
computer science that could possibly solve this. What's it for loop to solve this rule? Have to be a better way. Has to be another way, otherwise that's just too slow. 6 out abilities. Do. 6 out of 10. 1 goes through. Goes through 1 through 6. I mean, the probability is going to be symmetric. 2, 3. This thing ends up being the same as these. This one is going to cascade this thing. There's one way again here, one way again here. 1, 2, 3. Wonder. There's one way getting here, 1, 1. I take this plus what's there. It's the number of ways of getting to here. How does this work here? So on the first pass, it's all uniform. On the next pass, it goes 1. In the next step, it has 1 plus the number of ways of getting to this step. 2. And then this thing plus whatever's previously there. 3, 3 plus 1 is 4, 5 plus 5, 5 plus 6. And then if there's nothing here, then it's just going to go downwards. And what is the current process? And the next step is 1. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. So I have 2 arrays. I have 2 arrays. One is kind of the current rows, and one is the next rows. Oh, that's fucking. So it's gonna go 1 through. Yeah, it's gonna be like nested for loop. It just doesn't work if max points is this big. 10 to the 4th. So go 10 to the 4th for each loop, for the length of each thing here. It would be n squared. It would be 10 to the 8th. Which I guess is less than a million, but still too long. Is there a direct way of solving this? Take 10. Take 0 is expected value of all calculations. The rule infinite number of times you put negative 4.5 divided by 4.5. The expected value of all the rules is 0. Even though at some point the sum has to be between 17 through 17. Even though at some point the sum has to be 17. The value of the translator rule is 0. Expected value of the actual rule is 5. Twice. Two rolls is 11. Two rolls is 11. Probably that it is 17 more two rolls. Probably is 16 or less after two rolls. Those groups have to be equal to be 11 weighted average. 0 on the translate average. 0. The value of number of rolls for the game to 10. Number of rolls for the game to 10. 17. Sixteen divided by 5.5 is the number of rolls. It doesn't need to be exactly 17 expected value wise. That's the number of rolls you expect the game to end. Expect the game to end. Expected value is the minimum value. If you expect the game to end there, that's almost like half the time the game ended because it's less than 17. is quadratic. The next one will probably be cubic, I guess. We start with 1 here. 4 plus 3 is 4. 4 plus 6 is 14. 14 plus 10 is 24. That gets real big real fast. 2, 3, 4. All lowercase. There's a company that actually uses this for interviews. Good for them. Yeah, it's a high bar for screening. Good for them and good for anyone who can get this answer immediately. This median answer. This answer too. I'll go on a limb and say it'll be a impressively not medium answer to this. 10 to negative 5, the actual answer. I wish my stats was just better. Please, the probability of us. How do you get the probability of predictor outcome distributed random event after some number, or maybe not after some number, but just given its range of outcomes that could be for success or failure. One over every other. It's like some expected value. Expected value. Like 17. It's going to uniformly 1 through 10 before it. It's like 16, 15, 14, 13, all the way down to 7. It's likely to have occurred before 17. Can't go backwards. Can't go 2 to 11. Uniform 2 to 11. 2 equals uniformly to 3 to 12. 4 equals uniformly to 14. We have the layers. Be able to say it's still uniform. So given that it's at 16, uniformly goes through to 17 through 26. Then it's probably 16. How many cases would that be? One goes uniformly through 2 through 11. 0 goes uniformly to 1 through 10. What if I had what if I had u? What if I had a q where start a string value? So if I'm at 0, then at 0, then I'm going to say the next n things have a 1 value. And then so I q something like 10, -1, 10, -1 to represent that at 10 I'm going to go down by 1 value I'm dealing with. And then I iterate to the next one. Now I'm at 1 value. And then I'll say q at 11, -1. So then 0 to q that q plus 1, and like at 10, 10 away from now I'm going to go down. And next time I'm at 1, and 1 is currently at plus 1. And then I'm going to q plus 1, and at 10 from here I go down -1. Go down the amount that I'm up.
So I'm currently up +1. So I'm going to go down 1. And then 2. I'm at +2. 0. I'm at +2. And then at 12, I'm going to go down 2. Any sort of sense? I don't think so. Feel right. Well, was it not? 0. The number of ways I got here is 1 way. So I'm going to queue that for the next number of outcomes. The number of ways of getting there would be equivalent to the number of ways I got here. Number of ways I got here. If I distribute the whole, each step is a wall. Each step is a wall. Sum of it. Numbers. This is going to equal 10. Or I guess this equals max points. 1. And then I guess this equals max points squared. Max points is 6 here. 1, 2, 1, 2, 10, 20, 25, 36. Why does it equals? Do I even? The number of ways you get to a particular outcome, you kind of flatten it out. That's the number of ways you get to the next set of outcomes after that goal. But if I didn't have this to look down on, then we'll look at from a particular number point of view. Then the number of ways to get to that number is going to be, I can do 1 over that number of ways. If, let's say there's k ways to get to this outcome, I can do k divided by p, where p is the number of possibilities from the rule for each of the next p outcomes. Or I can just multiply that by p and just say the next p outcomes will have the same number of ways. So I'm at outcome 0. There's 1 way to get to outcome 0. And then if it's 6 I die, then the next 6 will have the same number of ways as me. And the total should be equal to the number of rolls, or p to the number of rolls.
1 or page 7 hasn't done this. Page 7 do it. Propagating it. Kind of. So 1 is going to go to everything from 1 through, say, 6. So no, outcome 1, and there's 1 way. And I'm going to propagate that. There's going to be the same number of ways, which is 1 to everything from here. Then at 7, I'm going to go down 1. And then not 2 and 2, there's going to be 1 way. So there's going to be 2 ways here. And then I'm going to say that at 8, it's going to go down. So it's going to be plus 2 to everything after this. And at outcome 8, I'm going to go down 2. And at 3, I'm at a total of 4. So plus 4 to everything after this. And then at 9, I'm going to go down 4. Work. This is fucking work. Would calculate 1, calculate 2, calculate 4, calculate, I think calculate 6 correctly. And then I have to do something to solve the actual thing. So again, the time when you have the answer, what does that mean? From ways. 1, 2. Okay, so what if I try to do basic thing here, which is roll once and get less than or equal to 6. We'll roll 1 through 10. So how would I model that? Or do I want to do something even simpler? So we can roll good. Let's start at an outcome. It starts at an outcome that is an end outcome. Then it shouldn't roll anymore. It shouldn't roll anymore. Right? The number of ways to get there. The number of ways you get there just starts tabulating. So every ways that you get to everything else after this is going to be equivalent. I guess. I'm doing this. And then the next thing is the same number of ways you get to the current thing. So you need to use modulo
increasing like this much. I don't know, maybe not. Maybe 10 to the fourth. It says is at most 10 to the 4 times 10 to the fourth. That's still smaller than the size of an integer. Okay. So you keep track of a queue where you add to the queue a tuple of what is your end spot and what is your decrementing value of outcomes. Okay. So let's say queue and give me double in the queue. I think it starts off with empty. Push something down. The weights counter. Let's say it's 1, and total is going to be incrementing. The total in range of 0 to, let's say, and 0 up to um, say the number of ways I got here. I form a tuple of that. So you append the number of ways I got here. This probably should just be an array, right? Where the array has an offset that I want, or the decrement value that I want a certain total. Okay, yeah, it's not view because I know that it's going to end. It's going to end x number of points away from the current total. So decrement total is going to be an array, say 0 times, I don't know, k 0 times n plus 1 maybe. Maybe it's n plus max points, maybe something like that. Let's say max points plus 1, just be extra safe. Okay. So I don't think I need, so the decrementing total in the index that is the current total plus the number of max points. So if I'm at 0, and there's one way to get to 0, then I'm going to say there's going to be one way to get to everything that would be rolled from 1 through 6 away from 0. So that'd be 0 plus 1 to 0 plus 6. And then starting at 7, so maybe max points plus 1. Total is currently 0, max points at 6. Plus 1 has a decrement of whatever the current number of ways is. And technically I need to start by removing it from here as well, so I'll say remove ways minus equals the decrement total for this number at the current spot. Okay. Open to 1 through 6. And then the current total is equal to the current number of ways. Ways plus equals the current number of ways. Current number of ways to get to here is going to be sum. Current number of ways to get to here. Zero, and then from there should be what's going on here. Zero. And then at the next iteration it starts with 1 way. And it should start with 2 ways. The number of ways otherwise. Definitely shouldn't be doubling numbers. So what should be doing? Should be getting 1. So 1. So the number of ways I'm getting here should be incrementing this by 1. So everything here from here to here is incremented by 1. I see. I should be tabulating the incremental. So it should be change in the total at certain value. Change in the total up by 1 here and down by 1 here. And then change in total up by the same amount and down by the same amount. Okay. So this is just going to be a change in total. So ways plus equals change in the total. I guess I can say this is the delta, whatever, change in total. And it's going to go change the total in the total plus 1 is equal to the number of ways here. And the change in the total plus 1 plus the max points is the negative number of ways to get
Okay. So this modifies the next process. Next outcomes. Base on a roll on this total base. Change. So this one. So my total is 0. The ways here is going to be changing the totals to be 0. The ways currently is 1. I'm going to change. I'm going to say that it's going to increment the next total 1 by up by 1, and then down by 1 at 7. And then at the next iteration, the total is 1. It's going to increase the number of ways that are currently here, which is 1 by 1. So now there's 2 ways to get to here. And then it's going to say there's going to be an extra extra 2 ways to get to the next number. So this is going to be plus 2 to get to 3. Yeah. And then minus that. Those goes maybe. I guess I can probably just go to length of change total. And I can say, and I guess I can stop it here if I say if the total is greater than or equal to k, answer all outcomes 0. So total of this thing is all outcomes. It's going to be yeah, all outcomes should be increased by the number of ways, and then all if the total itself is still less than or equal to n is the answer part of this. Number of ways. And then return the number of ways divided by, or return the number of answer ways by the all outcomes. Wonder. Backwards. No, it's not backwards. Out of range. Total plus 1 plus max points. Is this one off? Change 10 plus max point plus 1. Probably off by 1 or something like that. Maybe I can make this plus 2.
Assign an index item range. Total plus 1 plus that. Oh, okay, yeah. I only want to change the future outcomes if it's not already this. Okay. If I'm not already in the end collecting state of getting outcomes. Oh baby. Once. So it starts with totals 1, or to start with total 0. Ways should be incrementing by 0. So ways should stay at 1. Totals is not greater than equal to k, so totals can be 0. So change total at 1 is going to be equal to number of ways, which is plus 1. And change total at 1 at 11 is going to be negative 1. And at that point, we should go 1. What outcomes should be incremented by 1. Actually, that's not right. It's going. The number of ways to actually start with 0. It's probably getting not too big, or my number's too small. So 0 here. You're going to say the next number of ways. Actually, maybe you should start with 0 here. Start with 0 here, and you should have maybe a start of plus 1 here. Plus 1 here, and minus 1 there. Maybe you should start with 0 here. Then it'd be adding 0 to that right there. Minus plus equals. This thing is going to be 0. And then store 1 into this thing, 1 into this thing. So the way start with 1. So the number of ways to get to 0 is 1. And that should propagate to there and there. So you increment. So maybe just take the number of ways that. So if there's one way to get to this one, then
get to the 1. So you should start off with plus the number of ways here on the next iteration. Plus the number of ways here on the next iteration. Right? Change plus 1. One here and then 1 here. Increasing by 1, increasing by 1. This point, you're going to say increasing this thing by 1 here. And then decreasing by 1 here. Track of the total change. So the number of ways here increases the total delta. The total delta. So you change the total delta by the change total. So x number of ways of getting to a number, then it should be plus x to that number here, and then minus x here. There's all the ways they get to this number. Every number 1 up to the dice roll away from it. It's going to be plus x and minus x. All the ways you get to a certain number. So there's one way to get to 0. So starting at the next number, you have plus 1. And after that number rolls, you have minus that. So you should just start with ways is equal to change total. It's not the increment. I don't think. Fuck. This plus x and minus x, that's going to be that needs to have some sort of memory to it. Because this is going to be taking this plus x plus x plus x plus x plus x. It's 1 each here. Change number of ways. Number of ways to change delta. So this is going to be like the acceleration. So delta starts with 0 and increments change. Okay. I think maybe I should be having a delta plus equals to change in the total. And then the ways, it's going to plus equals delta. Ways plus equals delta. So, yeah.
change totals change based on the number of waves. Okay. Farther away from the answer. So it should be 0. Okay. I think I need to just see what's going on here. Print total, say current waves, and the change total array. I just need to know what this is. I'm gonna spell total. Okay. With 0. Circle is the right thing to call this. So the ways to get to 0 is 1. Delta is 0. And this is going to be 1 and -1 here. And then next time total is 1. It's going to be 2. The number of ways here is 2. Still 1. Why is this thing not? There should be like a +2 and a -2. Ways. Oh wait, this is all in the outcome. Total greater than equal to. Answer. Total is in answer range. So this is going to be ways. It shouldn't be increasing at all, actually. It should be flat. One roll. Because it should have been. Delta went up to 1. So I guess it's the baseline. Increasing here and decreasing here. Should it always start off with the previous number of waves?
always kind of be a roll from that number ways. So it should never really increased. It shouldn't really increase. It should just decrease. I guess it should be just like this. You're just gonna start off with the previous number of ways. And then possibly decrease it. Make sense better. One. Oh. Where it's like you have three rolls of the dice. So 0 to 6. Start off with 1 here. Say these are indices. And start with 1 here. You're going to say that this is going to be plus 1 here, and minus 1 over here, or something like that. So at 1, this should be like a uniform 1 for 1 here. So then there's one way to get to 1. And that number of ways, you need to say that that is going to be the number of ways to get to 2. Number of ways to get to here. Number of ways to get to here. So there's initially 0 ways to get to everything else here. So are you modifying this thing to be plus 1 here and minus 1 here? So now you start off with 1 here. And are you modifying this to be plus 1 here? But the 1 here that you're plus 1 here is actually saying that it's actually keeping 1 increase from here to here. So it's like your delta is 1. So your delta is 1. The number of ways nope, here's this one. Yeah, actually. Ways just equals your delta. So it's 1 here. That means that it's actually 1 through. It means it's 1 through 1 here. The number of ways. One same number of ways. So the number of ways is modified by the delta. So this +1 here and -1 here. Ways would be 0 here to start with. Then we have here. Here. Man, this shouldn't be this hard. Should not be this hard. So the number of ways to get to a certain number. Just the number of ways to get to delta. Increasing delta here, decreasing delta here. Number of ways to get to a certain number. But these are commutative. Change the delta, then it's going to stay that number until some other index. Zero, increase by 1. And do I have a starting number? Starting number. And the starting number is +1 here, -1 here. So it changes by this +1. That's kind of your baseline. The baseline doesn't change at all. Baseline changes based on your delta number. The baseline should be 1. Isn't my number of ways my baseline? So if there was an actual number here, so the baseline would affect so this is my delta number. My delta number changes my base. With +1, then the delta should only affect it on the once. If that's a once, then it should be the same value. So my number of ways minus 1 here, and then like plus 1 here, and minus 1 here. One, two, three, four, five, six, 5, 4, 3, 2, 1. Let's see how. Plus 1 minus 1 needs to give me a flat uniform ones. Plus second plus 1 and second minus 1 needs to give me a 1, 2, 3, 4, 5, 6. Spot. Number of ways to get to that spot. It would set equal number of ways to get to each of the spots 1 and max points away. Delta one minus 1 plus 1 means that your baseline is going to be